Finding an angle in a right-angled triangle. By the end of this presentation, you should be able to calculate all of the angles inside of a right-angled triangle. So, inverse ratios. We have opposite operations for every operation that we have, basically. So, opposite of adding is minusing, subtracting is plussing, multiplying, dividing, timesing, dividing is timesing, and squaring is taking the square root. So to undo a trigonometric ratio, which is just another operation, you need to apply something called the inverse ratio. So the inverse ratio is designated or shown by this little -1, and it's basically moving it to the other side, and you apply the inverse ratio on this opposite over hypotenuse, or your ratio. So you can do the same thing for cosine and for tangent. So cos theta is a over h, which means that your theta would actually be cos of -1, cos inverse of a over h. Same deal for tangent. Now the language of this, when you're actually finding you've got the angle, so we're not doing the inverse, when it's just the normal sine 58, we'd say sine of the angle 58 is equal to 0.8480. This is your length. So this 0.8480 is a length. So sine of the angle is equal to the length. Whereas if you're dealing with an inverse, we would say that the angle whose sine is a length is equal to an angle. So it gives us that, I suppose, flip of language. The steps to find an angle given two sides. So we know two sides, we're after finding an angle inside. First step, as per normal, draw and label a diagram. Once you've labeled the diagram, finding the two values that you have, you can then identify what ratio to use and substitute in the known values. Write the equation to find an expression for theta. I take the inverse, and then you need to use your CAS to do your calculations, and from there on in, it's a case of making sure your accuracy is right. This example here, for instance, we're asked to calculate to 2 decimal places. So first step, label the appropriate side lengths in your right angle triangle. So opposite the right angle is the hypotenuse, opposite the angle is O, which means the ratio we're going to use is so. We're after an angle to 2 decimal places, so sine theta equals O over h, and then substituting in what we know, theta is going to be equal to sine inverse of O over h, sine inverse of 4 and 9. So I've done a rearrangement before I've done my substitution. It's up to you whether or not you do it this way, or if you do your substitution right back up here and then do your rearrangement. You will get out the same result, and there's no right or wrong way to doing that. This is now a calculator question, so check to make sure your calculator's in degrees, then use the trig function, and then get it out to the appropriate degree of accuracy, so 2 decimal places, 26.39. Just like if we were dealing with lengths, you need to add a unit to this. So this is a degree, so put a degree symbol. Example 2, find the angle in the diagram correct to 3 decimal places. Label my sides. I've got O and A in this case, which is tan. So tan theta is equal to O over A. I can rearrange that formula. Theta is equal to tan inverse of O over A, where O is 5 and A is 8. And then I put this one into my calculator again, and I get out a result of 32.005. Again, make sure you put in that degree symbol to represent your units.